Okay, so now we're going to go over page 2. Okay, the first one is going to be multiplying the polynomials. Now this one has two terms in the first one in the first parentheses and two terms in the second parentheses. So we can simply use the FOIL method here. Let's see, the first two terms, x squared times 4x squared would be 4x to the fourth. And then the outside two terms, so plus 8x squared minus negative 5 times 4x squared would be negative 20x squared. Then minus negative 5 times 8, which would be negative 40. And then combine our terms. So this is simply just the FOIL method. And then 8x squared minus 20x squared will give us negative 12x squared, and then minus 40. And there's our answer there. Okay, the next one. Now when you have polynomials when you're multiplying polynomials and one of them is greater than 2, you can't use the FOIL method anymore. Now what we like to do is use the box. So if you have 3 terms here and 3 terms here, your box is going to also be 3 by 3 with 9 total boxes. Let's say if it was 2 and then 3 terms in the second one, then your box would be a 2 by 3. Okay? So now what you do is you take your polynomials that you're multiplying, put 1 on top, and then put the x to the fourth, negative x squared, and then positive 5 on the top, and then x cubed over here, 3x here, and negative 1 here. That just came from the second polynomial. Now you just multiply everything out. So now the first one here will be x to the 7th. And I'll go from left to right. And the next one here will be negative x to the 5th. And then this will be 5x cubed. Then going down to the next row, 3x times x to the 4th be 3x to the 5th. And then 3x times negative x squared is negative 3x cubed. And then the next one will be 5 times 3x, which would be 15x. And the next one at the bottom here, left to right, negative 1 times negative x to the 4th would be negative x to the 4th. Then negative 1 times negative x squared, it just becomes positive x squared. And the last one will be negative 5. Now what you're going to do is combine all the like terms. Okay, so I'm going to start with the highest degree. Highest degree is 7, so that one goes away. Then the next would be, there's no 6, so there's a 5, and I see one here and here. And so let's combine those two to make positive 2x to the 5th. So I'm done with those. And then the next degree will be 4, and I have 1 there. So I only have 1, so we'll just write that one down, minus x to the 4th. And the next one would be degree of 3. So now combine those two, negative 3x cubed plus 5x cubed, which will be 2x cubed. Okay, and then the next one would be squared, and I only have one of those, so plus x squared. And the next one would be just x, and I only got one of those. And then the last one is minus 5. So you'll see that this one ended up having 7 terms in there. Okay? And that's it for that. Now let's move to the next one. Now evaluate the polynomials given the values. Now again, you guys remember, when you're evaluating, you're just plugging in this number and seeing what is the result or the value after you plug in negative 5. So I'm going to show you the way that we've always learned, which is substitution. So which is basically just plugging it in to wherever there's an x. So then f of negative 5 will be equal to negative 5 cubed minus 2 times negative 5 squared plus 5x, sorry, not 5x, 5 times negative 5 minus 7. And then you just multiply, add everything up, and that will get you your answer. Now the new method that I just taught you guys is to use synthetic division to solve this problem. Okay, so now first thing is, obviously, as always with any division problem, with the division techniques I taught you, make sure there's no missing terms. And I don't see any missing terms here. So we can go ahead and set up our problem. Now the number that goes in the box, normally you would say, oh, well, if it was x minus 2 when we're dividing, you would do whatever I'd have to plug in there to make it 0, and I would put 2 there. And it would basically be the opposite of whatever that number is. But here, when we're just evaluating, you just plug in that number. So negative 5 goes there. And then write down the coefficients like we did before. Draw your line, and the steps are the same. So now bring down the 1, the leading coefficient, negative 5 times 1 is negative 5. Add up the column, or simplify it, get negative 7. Then negative 5 times that new number, negative 7, would be plus 35. Add those together, I get 40. And then negative 5 times 40 is negative 200. Then add that column together, I get negative 207. That last number, which normally when you do the division is your remainder, that's going to be your answer when you evaluate. So now f of negative 5 will be equal to negative 207. Now in the test, I'll expect you to know how to do it with the synthetic division technique to be able to evaluate that. And again, remember this number here ends up being your not your remainder, but ends up being the actual answer. Okay, so now let's do that one more time with the next one. Now again, it'll ask you to do it both with substitution, where you just plug the number in, and you can use your calculator or just do the math yourself. And then it'll ask you to do it synthetically. Okay, so now make sure you got all your terms. In this case, we don't, because we're missing a x squared term and an x term. So rewrite it out: x to the 4th minus 2x to the 3rd, then plus 0x squared plus 0x plus 1. Now, in the box, again, write that x value, and then all your coefficients: 1, negative 2, 0, 0, and 1. Bring down the leading coefficient, multiply, not negative 1. And then multiply the box number times that coefficient, and you'll get negative 1. Add the column, negative 3. Multiply negative 1 times negative 3, positive 3. Add the column, get 3. Negative 1 times 3, negative 3. Add that column again, negative 3. Negative 1 times negative 3 becomes positive 3. And then that column there, add it together, there's my answer of 4. So now the f of negative 1 is equal to 4. And again, just remember, I'll expect you to know how to do it both ways, both by just plugging it in to wherever there's an x, and then also being able to do it synthetically like we just did there. Okay, let's move to the next one. Now the box method. I did create a video. I know it says not in the video, but I did create a video, which is also online. It should be in the list of videos that was right under this one. So let's go ahead and do this one. So again, make sure you're not missing any terms. And it looks like we have x to the 3rd, x squared, and x, and then a constant, so we're good. So the first thing you do is you take your divisor, or what you're dividing by, you put that over here on the left. Let's do a different color. Put the x and then negative 2. Then you take your first term, and it goes in the first box. And like I showed you in the steps in the notes, I like to highlight diagonally, because it helps me keep track of what I'm doing. And then whatever you highlight the first column, you highlight that next term in your polynomial. And then pick a new color. And during the test, you're welcome to use my highlighters as well in the class. And then pick a new color. and then do the next term, which happens to be the third one. And then we have a fourth term here, which I'll use blue in this case. Do the next diagonal, and that will be this last term, 10. All right. Now, what you're going to do next is the first thing is you say, what do I have to multiply times this x to equal 2x cubed? Well, I would have to multiply 2 and then x squared. So that number goes on top. And then what you do is you fill in the column below by multiplying this number on the side and the number on the top. So negative 2 times 2x squared will be negative 4x squared. And now you got to figure out what goes in this box. So you do that by saying, what do I have to add to negative 4x, this number down here, 4x squared, to equal this term here, our second term? Well, I'd have to add positive 9x squared. That's how we fill that box in. Then you say, what do I have to multiply again times this x to equal 9x squared? Well, be 9x. There's our second term for our answer. And then below, multiply it out. So negative 2 times 9x is 18x. Again, go back up to the original polynomial and say, what do I have to add to this negative 18x to make it equal negative 23x? Well, that'd be negative 5x. And then, again, repeat the process. What times x equals negative 5x? Well, negative 5. And remember, if you remember, once you get a constant on the top, that means my next number down here will be my remainder. So write an r there. Once I get a constant over here, a number that has no letter or no variable, write an r, because I know that last number will be my remainder. So now fill in the column. Negative 2 times negative 5 will be positive 10. And then I say to myself, what do I add to this 10 to make it equal 10, the last term in the polynomial? Well, it's just 0. So my remainder will be 0. And now I take those terms I found on top, and I have 2x squared plus 9x minus 5 plus 0 over what I divided by, which is x minus 2. And again, that's equal to 0, so I don't need to write it. So that will be my final answer there. Okay, next one. Okay, first step, make sure all your terms are there. Looks like we're missing an x squared term. So I'll have to do x, let's write this actually over to the side so we don't run out of room. X squared, x to the cubed plus x 0x squared minus 2x plus 1 divided by x minus 3. All right, now we're ready to fill in all the rest of our box here. So we put our divisor on the left, x and negative 3. And then in the first box, we're going to put the first term. Then I'll do my highlighting. Yellow here, and then the second term, which happens to be 0x squared. New color, we go to my pink. Pink there, pink here, and then the third term, or the next term. And I have one more term, so I'll do blue. And that last one term, which is 1. All right, now let's go back to the far left, top left. What times x equals x cubed? X squared. Then fill in the bottom. Negative 3 times x squared, negative 3x squared. Then what do I have to add to that last number, negative 3x squared, to make it equal 0x squared? Well, I'd have to add positive 3x squared. And then repeat the process again. What times x equals 3x squared? 3x. Fill in the bottom. 3x times negative 3, negative 9x. And then what plus 9x? Negative 9x equals negative 2x over here. Well, that would be positive 7x. And then what times x equals 7x? Well, 7. And then the last, then the bottom here, 7 times negative 3, negative 21. And remember that last term happened to be a constant, so that means my last number is going to be a remainder. Now, what do I have to add to negative 21 to make it equal plus 1? Well, I'd have to add 22. So now my answer goes as follows. X squared, and remember I'm using the top terms, plus 3x, plus 7, plus my remainder, 22, which I put over x minus 3. And there's my answer. Okay, let's go down. And now we're going to do the same problems we just did above with synthetic division this time. So now, set up your box with synthetic division. And remember, this is the case where x is a liar here. Because that number that goes in the box is what number do I have to plug in here in this x to make it equal 0? Well, that would be 2. And then make sure you have all your terms, no missing terms. Looks like we're good. So now you write the coefficients, 2, then 5, then negative 23, then plus 10. And then first step, bring down the 2. 2 times 2, 4. 5 plus 4, 9. 2 times 9, positive 18. Negative 23 plus 18 is going to be negative 5. And then negative 5 times 2 is negative 10 and 0. Now that last term there, remember, that is your remainder, which happens to be 0. So, and then if you look on your notes, that last step it said that the first term, the degree of it is going to be 1 less than the original polynomial. Okay, so that means the first term will be 2x, let's do a different color, 2x squared instead of cubed, plus 9x, and then we just go in descending order, minus 5, plus 0, the remainder, over x minus 2. But again, that cancels out, so our answer is just this here. And it should be that, because if we look up here, in the problem before, or above, it's the same, should be the same answer. Okay, so if you're working on this, and you got a different answer, top and bottom, then you did something wrong on one of them. Okay, down the next one. Let's make sure we don't have any missing terms. Looks like we do. So let's rewrite it out. Looks like we're missing an x squared term. So x cubed plus 0x squared minus 2x plus 1 divided by x minus 3. So now let's write out our, first write our box. And the number that goes there is going to be 3. Because x3 minus 3 equals 0, comes from there. And then our first term will be 1, then 0, then negative 2. And the next term will be 1. Then we bring down this 1, comes down here. 3 times 1 will be 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 2 plus 9 will be 7. 3 times 7 is 21. Then add up that column. 1 plus 21 is 22. And then our final answer will be x. Remember, our first leading term in the original was cubed, so the first term here will be squared, plus 3x plus 7 plus our remainder, 22, over x minus 3. Okay, so this is the case where the remainder is actually not equal to 0, and you would have to write the remainder there over the original divisor, whichever you divided by, which happened to be x minus 3. Now, just a reminder, as I included in your notes, in 6th period, I believe I missed this, I apologize. The reason we even do dividing like this, or the result of it, I should say, what it actually tells us is that whatever we divided by, so in this, let's see, the problem on the left, we divided by x minus 2, and the problem over here, we divided by x minus 3. If we divide it into the original polynomial, and in the remainder it happens to be 0, like it is over here on the left, that means that that x minus 2 is actually a factor of the original polynomial. So that x minus 2 is actually a factor. So like, you know, when we factored out the problems, and you would, with zeros, and you get x minus 2 plus x minus 3, this is actually a factor of that original polynomial. Okay, so if we divide it in there, and it comes out with a remainder of 0, we know that it's actually a factor. But over here on the right, where we try to check if x minus 3 is a factor of this original polynomial over here, x cubed minus 2x plus 1, we came out with the remainder of 22 over x minus 3. So that means it didn't go into it evenly, and it's not a factor. So we could say this, or no, let's say this, is a factor and not a factor. Okay? All right, I'm stopping here, and I'll do another video for page 3.